So let's look at this idea of factorising, because the very first idea when we're factorising is to look for a common factor. I mean, that's the easiest way to simplify something down. So never forget that. It's surprising how often people forget to just simply look for a common factor. Once you've done that, the number of terms that are there usually determines what type of method you use in the approach. So if I've only got two terms, things I'm looking for is difference of two squares. That's something that usually ends up with two terms. Sum and difference of two cubes. If there's three terms, well, the simplest type of three-term one we got is the good old quadratic. So is it a quadratic trinomial? Can we factorise it that way? If there's four terms, then usually we look for grouping in pairs and have a look at that. So they're usually the ideas we go through when we're trying to factorise. So first of all, remember, factorising is simply dividing by the common factor. That's all you're really doing. Some people get confused and they go, well, if I take this out, what am I left with? Well, simply divide by whatever it is you're taking out. Tricky. AX plus BX. Yes, there's a common factor of x there, and we get a plus b. This one I used to illustrate 5x squared minus 10x. There's actually two common factors there. Some people just pull the x out, some people just pull the 5 out. But no, we pull out all the common factors. Common factor. Oh, that's okay, x is in there. Oh no, it's only in the first two. Oh, that's okay, look, m and m, oh, it's only in two. Oh, no, that's all right, look, we've got n and, oh, it's only in two. Oh, but why, oh, it's only in two. So this is one where I say, hang on, I've got four terms. Grouping in pairs, it really is like common factors. Pair them up and we'll see that I've got, oh look. But the trick of course with this one is, what's left inside the parentheses, you want to try and make that the same. And that's why I've taken out a negative common factor there, a common factor of -1 rather than leaving it as +1. So now I can re-look at the question and say, now I've got two things, but they've got a common factor of m minus n. So now I can pull the m minus n out, and I'm left with x minus y. Okay, difference of two squares. Really, it's just the backwards of what we saw before when we were expanding. So if we see that pattern a squared minus b squared, we know it came from the difference of two squares. So I see 16x squared minus 1, and I go, oh, hang on, yeah. That's 4x all squared minus 1 squared, so brilliant. Put the negative first, put the positive first, doesn't really matter. Technically, it's the negative one goes first. 3y squared minus 75, you go, oh, hang on. No, they're not perfect squares. Always look for the common factor first. There is a common factor there of 3. When you pull the 3 out, now you're left with a difference of two squares. That's why you always look for that common factor first. And now we've got the y minus 5, y plus 5. Oh, again, 4 terms. No, can't see common factors. It actually is a grouping in pairs question. If I grab the first two together, I can write that as 5 outside x minus y. The second 2 is difference of two squares, but I now have two things that have a common factor of x minus 1, x minus y, I should say. And there we are, x minus y, 5 plus x plus y. Quadratic trinomial, and if we're lucky, it's monic, makes life so much easier. A monic, of course, meaning that the coefficient of x squared is 1. And if you think about it, well, x plus a, x plus b, if I was to expand that out, I would get x squared plus a plus b lots of x plus ab. That is why we always say what multiplies together to give the last number, what adds together to give the middle number. That's the key to finding these. So x squared plus 9x plus 18, perhaps when you first started doing these, you wrote a little note on the side, went, what multiplies together to give 18, adds together to give 9, factors of 18. There's other things we look at. We can see they multiply together to give a positive number, so we know we're looking at two positives or two negatives there. They're adding together to give a positive number, so therefore it must be two positive numbers I'm looking for. And of course those numbers are 6 and 3. 6 and 3. T squared minus, so what multiplies, again it's positive, but adding together to give negative numbers, so it must be two negative numbers this time. And don't forget there was 3, of course, being a prime number makes it very easy. It has to be 3 and 1, there is no other possibility. So we have -3, -1. Whoa, x and y's. Don't worry about the x and y's, it's the numbers that are important. I mean, technically we're saying what multiplies together to give 4y squared, what adds together to give negative 5y. But as I say, the y is irrelevant, it's the number. So we want negative 4 and negative 1, but instead of writing down negative 4 and negative 1, we write down negative 4y and negative 1y. There's our factorisation. Splitting the middle. Well, the reason why splitting the middle is, to me, such a good method is you don't have to change your way of thinking, and that's why I prefer it over the cross method, because I'm still saying what multiplies together to give a certain number. The difference is, I don't say negative 7, I always multiply the constant with whatever the coefficient of x squared is. So I'm going to say what multiplies together to give negative 21 and adds together to give 4. But it's still the same thought process. I don't have to change my thought process. Multiplies together to give a negative number, so I'm looking for a positive and a negative. The positive number must be bigger, because when I add them together I get 4. Factors of 21, well, it's not a lot, 7 and 3, they differ by 4. So it must be 7 and negative 3. And you do exactly what the method says. You split the middle into those two, and you now have a grouping in pairs question. Pull out the 3x, pull out the 7, and bingo, you got it. That's it. No more thought process. Okay, let's try it. So in this one, I'll say what multiplies together to give negative 24, adds together to give negative 5, multiplies together to give negative 24. So again, must be a positive and a negative, adds together to give a negative number, so this time the negative number must be the bigger number. Factors of 24, it's got a lot of them. They got to differ by 5. What's that? 8 and 3, yeah. So we go minus 8x plus 3x, group it in pairs, we have our answer. Alright, so 1C